Well, hello future programmer. In this very first tutorial of my Java tutorial series, I'll be teaching you the core basics of Java, including displaying text to the user and creating variables and doing simple math operations with them. To get started, you're gonna need to have an application to program in. I'm currently using the free version of IntelliJ IDEA, and there's a link to a video on how to install that in the description of this video. But first, if you see me do something you don't understand, or you want to know something else about programming in general, you can leave a comment down below and I'd be happy to answer it. Now that being said, we're gonna need some document to type our code in, so go to Source, New, Java Class, and give it a name starting with an uppercase letter, so for example, current lesson. We now have our first Java class file and we need to tell Java that this is indeed a Java class file. And to do that you type public, meaning every other Java class file can access this file, and public is a keyword, and keywords are just words in Java that have a special meaning, and I will be going over all of these keywords in numerous new videos. Then we have to type class, meaning that this is a class, and then the name of the file without the extension, so current lesson in this case. And then we're gonna need to create a body by doing two curly brackets, and everything between these two curly brackets is gonna be part of your class. Now that Java knows this is a class file, it's gonna look for the main method, and the main method is the code that's gonna be executed when your program starts. So to create this method you go public, meaning every other method can access this method, then static, meaning that this method belongs to the class and not to an individual object. And I know that doesn't make sense right now, but we will be covering that in later tutorials. Then void, meaning that this method doesn't return anything. Then the name of the method, main. Then we need parentheses, and in between the parentheses we're gonna give it the parameters. And the parameters are string, square brackets, args. Then we need to give a body to our method, just like we gave a body to the current lesson class. And we do that exactly the same by using curly brackets, and everything between the curly brackets is part of the main method. I know that was a lot to take in, and don't worry about remembering all of it just yet. You will get it sooner or later, but if you have a question about it, please don't be shy and ask it in the comments. But now that we have our main method and Java knows what to do when our program starts, we can finally do a lot more. For example, displaying text to the user. And to do that we have to call a method inside of another Java class that knows how to display text on the screen. And calling a method basically means to ask it to execute its code. Because a method has a body, just like our main method, and everything inside that body will be executed. To access this method that knows how to display text on the screen, we have to type System.out.print, and print is the name of this method. Then type parentheses, and in between the parentheses we need to give this method the information that it needs to display text on the screen. So in this case it's the actual text that you want to display. And in Java, if you want to give it some text and not just code, we need to use quotation marks, and everything between quotation marks will be seen as text instead of code. So if we want to say hello world, we would do that like that. And at the end we need a semicolon, so Java knows this is the end of this line. Then we want to execute our code by right mouse button, run current lesson.java, and as you can see it returns hello world. Now let's say we want to print this another time. Well, if we execute this, you will see that there's no extra line break in between these two sentences. And that is because print just prints the thing and then it's done. If you want an extra line break after it, you have to use another function, and that is called print line. So if we use print ln, print line, instead of print, it will put an extra line break after it, as you can see. Now let's say we have 4 print statements and we want to change all of them to by world. We would go by world over here and by world over here, and that would be kinda boring to do 4 times or maybe even 100 times. Now wouldn't it be handy if we could use a variable and only change the value of this one variable, and that all the print statements would print the new value of this variable? Well, we can do this by creating a string variable. And in Java all variables have a type, a name and a value. So the type would be string because the variable is a placeholder for a string. Then we have to give it a name. for example, by message. Then we have to assign a value to it by using the equal sign. And then the message, by world. And by world is the string, by message is the placeholder for the string, the variable name. Then a semicolon because it's the end of the statement, and then we can simply copy this name of the variable inside of the print line statements. And we don't need quotation marks because it is only a placeholder for a string. By message is not a string itself. So when we print this, as you can see, it will print by world 4 times. And by changing this one string to by worlds, all the print line statements will print the new message. Now think about this. If we use quotation marks to tell Java this is a string, can we print quotation marks themselves? We have to escape these quotation marks that we want to print. And you escape a character by using a backslash and then the character you want to use. And as you can see, you can escape all of these characters, so you can add a new line or a new tab, or you can escape the backslash itself. So what if we wanted to add a new line after by? It would say by worlds, in between quotation marks and with a new line. Because we use this syntax, /*, and here */, everything in between them is ignored by Java. It's just for the user to explain his code. And the same can be done for a single line of comment by using 2 /. So this entire line is a comment, but when we go to the next line, it won't be a comment and will give you an error. Now that we know how to use comments, I'm going to comment out these 4 print statements by going /*, and then at the end */. We now know how to make a string variable, but you can also make a variable of, for example, numbers or characters. And to do that, we have to use one of Java's 8 primitive types, and those are the byte, the short, the int, the long, the float, the double, the boolean, and the char or character. And you can see the description over here, and I'll give an example of all 8 of them. Let's start by creating a byte variable, so byte, my byte, equals 120, for example, because a byte can only be a number between -128 and 127. Then we'll create a short, my short equals 16,000, because a short can be between -32,000 and 32,000. Then an integer, int my int equals 2 billion or something like that, and it can be up to a few billion big. And then we have something even larger called a long, my long, and this is a special one because when we create a long, we have to use an L at the end, because without an L, Java will think, well, this number is way too big to be an integer, so I'll just give you an error. Well, by saying L, Java now knows this is a long and it won't give you any error. Then a float, my float is 2.5f. The same as with the long, we need to tell Java this isn't the default type for floating point numbers, because the default type for floating point numbers is a double. So we need this f to tell Java, well, this is a float and not a double. Then we have a double, my double is 3.1415, and the difference between a float and a double is that a double is much more precise, because a double has about 15 decimal places after the decimal point, and a float only has 6, so that's a lot more precise. Then we have a boolean, which can either be true or false, equals true, not 1 or 0, true or false. And then last but not least, there are 2 ways to represent a character, by the character itself or by the number that it's associated with. So we are first going to make a character using the number, so car, my car is 66. And the number 66 represents an uppercase B, but we could also just do car, my car 2, because you can't make 2 variables with the same name, and then B. And we have to use apostrophes to tell Java, this is a character, this isn't code or a variable name. For characters we use apostrophes, and for strings we use quotation marks. And these are the 2 ways to create characters. Now let's say we want to print our name and our age to the screen. We could put our name in a string variable, so string name equals Richard, because that is my name, and don't forget the quotation marks. And then our age in a byte variable, because I'm not older than 127 years, so that will do. We could first type System.out.print line and then print the name, and then do the same thing for the age. Or we could do all of this in one line. We're going System.out.print line, and in between parentheses, name, for the variable name of name, and then plus age, and then a semicolon at the end. So this will first replace name with Richard, then replace age with 17, and we'll just print the whole thing without a space, because we haven't defined a space after Richard. We can do that by just adding one over here, plus a string of just a space, and then another plus age. It will first replace name with the value of name, which is Richard, then it will add a space, and then it will replace age with the value of age, which is 17. Now let's make a nice sentence of that. Richard is 17 plus years old. It will say Richard is 17 years old. I will be turning 18 soon, so I would like to tell you that. Well, we could create a new variable, or we could just change the value of age. Well, we've already defined age, so we don't have to tell that it is a byte again. Age equals 18 now. So then we can do the same thing and print this out. Is almost 18 years old. Richard is almost 18 years old. And this 17 just remained the same, because only here it was changed to 18. Before that, age was still 17. Now what if I lie to you and I'm actually 18 years old? I would have to change age over here, and I have to change it over here. So wouldn't it be handy if I could just add 1 to the current value of age here? Well, I think it would. So we can actually do that by using this syntax. Age equals age plus 1. It will give an error, and I will explain that in just a second. But what this does is it just gets the current value of age, that's 18. It's going to add 1 to it, so 18 plus 1 is 19. And then it's going to assign that new value to age. That's what it does, and that works with all the types. With byte, short, int, long, float, and double. Now we can't do this because we're trying to add an integer to a byte. Because remember, the default type of non-floating point numbers is integer. And you can't add an integer to a byte. That's just insane. So to do this, we have to temporarily change age and 1 to a byte. And we do that by casting it. And you cast something by using parentheses, and in between the parentheses you put the type you want to cast to. You want it to temporarily convert to. And then what you want to be cast has to be in between parentheses as well. When we now run it, it will say Richard is 18 years old and Richard is almost 19 years old. And when we change this to 30, it will still work. It will say Richard is 30 years old and Richard is almost 31 years old. So that's how you do it. And you can change this 1 to any other number as long as it can fit inside of a byte. You can add, subtract, multiply and divide by other numbers, but you can also use something called the modulus. I'm going to print 9 modulus 4. Modulus is simply the percent sign, and when we're going to run this, it will return 1. Because the modulus will give you the remainder of the division. So 9 divided by 4 will give you 2 dot something. Well, then you have 1 left. 4 doesn't fit in that 1, so it will give you the remainder, the 1. So that's what the modulus does. We've just talked about casting and turning bytes into ints and longs into shorts and even doubles into longs, because it will just get rid of all the decimal places after the decimal point. Because remember, longs, ints, shorts and bytes don't have decimal places. So when you convert a double or a float into a non-floating point number, it can't keep the numbers after the decimal point. So it will just get rid of them. But we haven't talked about converting a string into a double or a boolean into a string. So let's talk about that. So I've created 3 variables to test this, and we're going to convert all of them to another type. So we're going to convert this first double, myPy, to a string. And you do that by saying double with the capital D dot to string, and then in between the parentheses we use myPy, the name of the variable, and then of course a semicolon. And remember, because we have parentheses over here, this is a method, and this method is inside of the double class, just like this is a class. Now our myPy variable is a string instead of a double. In the same way we can convert our favorite number, 17, to an integer, and to do that we use integer with a capital I and not the abbreviation, and then parse int. and then we use the name of the variable, so favorite number. And now we can do calculations with this number 17, because before it was just text, and now by turning it into an integer, it is actually a number. And to do calculations with this new number instead of this string, we need to save it in a variable. For example, integer a equals integer.parseInt favorite number. So a is now equal to 17, even though it was a string before. And the same can be done with booleans. So we have a boolean that's equal to false. Well, we want to change that to a string. So we go boolean, again with the capital letter, because it's about the class and not about the primitive type. Boolean.toString, and then the name of the variable, true or false, semicolon. And now this boolean has been turned into a string. So that's how you convert strings into other types and other types into strings. And to show you 17 has been changed into an integer, we'll multiply it by 2. So we do a equals a times 2, semicolon, and then we're going to print it. So when we run it, you'll see 34. But there's a shortcut to do this. Instead of a equals a times 2, you can type a times equals 2, and that will do the same thing. So now 34 times 2 equals 68. Now I want to change this 68 to 69, so we have to add 1 to a. And we can do that by typing a equals a plus 1 or a plus equals 1. That's a lot shorter, but there's an even shorter way if you only want to add 1 to something or only want to subtract 1 from something, and that is a plus plus, semicolon. So when we print this, it will say 69, and the same for a minus minus, so it will say 67. And that's about it for this tutorial. If there was something you didn't understand, please leave a comment and I'd be happy to answer it. And also if you want to know something else about something I didn't teach in this video, just leave a comment and I will answer it as soon as possible. But before you click this video away, in the description is a link to the source code of what we did today, and there will be a lot of comments in it like this with extra information about what everything does, so it's highly recommended to just read it and maybe code something yourself, because you already have a lot of information, so the possibilities are almost endless. Hopefully I'll see you all next time when we're going to talk about user input and maybe even a little bit of object-oriented programming. Bye bye.